okay, under group 2, okay, group 2 are called alkaline earth metals, okay. So these alkaline earth metals, okay, starting from beryllium, magnesium, calcium, strontium, and barium. And we need to know certain things, okay, when you look into these group 2 metals. Okay, they have, okay, when we look at melting point, okay, the melting point generally will follow a downward trend, okay, except for, okay, you can see that the magnesium is going to be extraordinarily lower, okay, and then there is going to be, or you can say the drop, okay, from beryllium to magnesium is a lot. Then after that, there is an increase. Then after that, continue to drop. Okay, so there is going to be abnormality when it comes to magnesium. So why is that? Okay, this one, when we talk about melting point, we are talking about the metallic bonding. Okay, we are talking about metallic bonding. So this metallic bonding is going to be the bonding between the beryllium, okay, for example, if you have beryllium 2 plus, and the 2 electrons from the C of delocalized electron. Okay, so if you have that, okay, and you have that, okay, the bonding between them, okay, that is going to be telling us about how strong, okay, is your metallic bonding. So when you look into that, okay, we know that as you become bigger, like for example, going down the group, you know that beryllium, magnesium, calcium, strontium, and barium, the metallic radius, okay, is going to become bigger. Okay, what is metallic radius? Is going to be the distance from the cation, the metal cation, and the C of delocalized electron. So when they become bigger, okay, the distance, okay, it means the metallic bonding is going to become weaker. Okay, therefore, okay, you can see the metallic bonding is kind of decreasing. Okay, but what is happening towards magnesium? This is outside of your syllabus. They will not ask you. Okay, they will not ask you. But if you want to know more, okay, magnesium, the way that they are going to be arranged, okay, is going to be the lattice, the way they are going to be arranged is different. Okay, therefore, okay, they have the metallic bonding is kind of higher, lower, okay, compared to calcium and compared to beryllium. If let's say they ask, okay, but I don't think so. They will ask about that. Okay, just remember, okay, the melting point is going to be generally decreasing. Why? Because the metallic bonding is generally going to be decreasing. Why the metallic bonding is decreasing? To answer that, okay, because the metallic radius is going to be increasing. Okay, because the metallic radius is increasing, the strength, okay, between the cation and the electron from the C of delocalized electron is going to become weaker. Okay, so that will explain this part. Okay, and the next part is going to be about the density. Now, if you want to go in detail, yes, you can go into detail. But if you look into density, density is mass over volume, and we know that, okay, we know generally beryllium to barium, okay, the mass is generally increasing. But again, as I told you, the way that the volume, okay, the way that they are going to be the volume of that metal is going to be different. So the mass and volume, they are kind of different. So if you look at from here, beryllium to calcium, you can see the density is going to be decreasing. Why density is decreasing? You can say that the increase, even though the mass is increasing, but the volume is also increasing more compared to the increase in mass. So therefore, your volume is always greater compared to the mass. Okay, the volume is always greater compared to the mass. That is from beryllium to calcium. But the moment you go from calcium to barium, what happened is, okay, the mass, okay, you can see the mass is going to be, the density is going to be greater. So it means that the increase in the mass, if you divide with the volume, okay, the volume, even though the volume is increasing, but it's not that increasing. So the increase in mass is going to be more than the increase in volume. Okay, therefore, okay, your mass is going to be greater number. compared to volume, therefore the density will go up. So that will be the one that will explain to you about the graph. So if you want to actually figure out, okay, how will they ask me in exam? Okay, they can give you graph and ask you, okay, what happened. They can also ask you to identify from here which one belongs to magnesium. Then you can identify this is magnesium. Okay. From here, which one belongs to, let's say, for example, barium. Yeah, so you can identify, if they give you density, you can identify this one belongs to barium. So this is how they can ask you. Okay, this is straightforward. Okay, straightforward, you need to know. Okay, but how we can memorize, how we can explain, of course, I've explained to you based on metallic bonding, based on mass over volume. And there is another one more thing that you need to know about this group 2, which is going to be the reactivity. Now, when we look at group 2, okay, they have 2 valence electron. Okay, 2 valence electron at the outermost shell. So it means that they have the tendency to lose electron, to lose the 2 electron. So in any chemical reaction, okay, we will look into ability of it to lose electron. So we want to see whether group 2 can lose electron easily or not. And as you go down the group, beryllium all the way to barium, we know the size or the shielding effect is greater. Okay, size is greater. Okay, and we know that the shielding effect, okay, and the distance from the nucleus is going to outweigh the increase in proton number. Okay, therefore we know that, okay, we know that the distance is kind of further away. Okay, further away. If you have 2 electrons here and then beryllium, the 2 electrons here, they are closer. What will happen? The 2 electron is going to have difficulty in moving away because the nucleus is going to hold the electron tightly. Okay, but because the distance is going to be so great from barium to the outermost electron, because shielded by the shielding effect and distance, okay, what happened is this electron can go out easily. Okay, therefore, if you are looking into reactivity, the reactivity, when we talk about electron, okay, it means barium will have tendency to lose electron easily. That is the reason why they are going to become more reactive going down the group. Now, please take note, this applies for group 1, group 2, and group 3. Okay, if you are talking about reactivity, ability to lose electron, when it comes to group 1, group 2, and group 3. But when it comes to group 5, group 6, and group 7, you need to talk about ability to attract electron. That is going to be different. Yeah. So this one, losing electron, okay, when we are talking about non-metal, ability to attract electron. So we will look at it when we are discussing about group 17 later. Okay, so I will move on. Now, what are the reactions that you need to know? Okay, first thing is going to be the reaction with oxygen. Okay, magnesium, okay, can react with oxygen, can be burned with oxygen to give you magnesium oxide. Now, this magnesium oxide, okay, when they burn, they give you a bright white flame. Okay, it is all taken from your textbook. Yeah, so they will give you magnesium oxide, okay, and then it will burn with bright white flame. Now, this magnesium oxide, okay, when you add with water, okay, they will give you, okay, they will give you magnesium hydroxide, which is going to be a weakly alkaline solution. Okay, and this, the reason why we have to learn about this, because that's the reason why it's alkaline earth metal. Okay, they are going to give you alkaline solution. Okay, so if you have, okay, when they react with oxygen, they give you oxide of that metal. When that oxide, okay, is going to be, we call it as a basic oxide. What is basic oxide? This basic oxide, when you react with water, they will give you alkaline solution, which is going to be pH greater than 7. Okay, so the similar thing will happen also, okay, when you are talking about calcium, okay, reacting with oxygen, they will give you calcium oxide. Okay, I didn't write it over here, but the same. If you have calcium oxide reacting with water, okay, it's going to be a vigorous reaction and they will give you calcium hydroxide. Now, all this, okay, will be also going to give you a weakly alkaline solution. The pH is going to be pH 11. Now, one thing that I want you to notice also for this is later I will teach you about the solubility of hydroxide. Okay, now the solubility of hydroxide, later I will come back to this again. When you look at hydroxides, okay, group 2 hydroxides, when they go down the group, this one you memorize only for your AS. Hydroxides, group 2 hydroxides, when they go down the group, solubility is going to increase. Okay, solubility is going to increase. It means that, okay, if I have magnesium hydroxide, then I have Mg 2 plus OH minus. If I have calcium, yeah, of course, I will have this. So if solubility is increasing, it means that, okay, you will have greater concentration of hydroxide ion. Okay, if you have greater concentration of hydroxide ion, as you go down the group, okay, you can say that it will become more alkaline. It means the pH, if I'm going to predict, okay, magnesium, okay, then after that towards the end I have barium. If I want to predict the pH of barium hydroxide, okay, what will be my pH? Most probably you can predict pH is going to be 13.3 or 13. Okay, why? Because, okay, hydroxides, okay, when you go down, okay, the hydroxide solubility will increase. And why? Okay, you have pH 13.3, okay, because, okay, the concentration of hydroxide will be greater. Okay, this one we will discuss this later part. In this part also, I will discuss about it. Now, the next thing is also to look at into the flame test. Okay, you can do a flame test, okay, using all these group 2 compounds. Okay, you take the nichrome wire, you take the concentrated hydrochloric acid, and then you take the salt and then heat it with the Bunsen flame. If the Bunsen flame, okay, the flame test gives you brick red color, then it's going to be representing calcium. Memorize, okay? Brick red color, calcium. Okay, if it is going to be scarlet or red color, it's going to be strontium. Barium, very popular. Barium will give you apple green color. Okay, this one you can memorize. Okay, just memorize only. Yeah, so I'm not going to repeat this again. Calcium, brick red, strontium, red color. Yeah, barium is going to be apple green. Yeah, so I'll just move on. Now, how about reactions with water? Okay, now always stay to the concept because you see, all these chapters are linked. Okay, like just now we are talking about group 2. Suddenly we talk about metal. Then after that we talk about metal oxide. Okay, after that we are talking about hydroxide. Why? Because they're all starting from the metal. Okay, we are starting from the metal. So when I put the title over here, reaction with O2, it means that reaction of the metal with O2 gives you the oxide. And of course, you need to learn about what will happen to that oxide. Okay, so you need to also learn over there. So you cannot just say, okay, magnesium react with oxygen, give you oxide. That's it. I don't want to learn anymore. Then you will end up to here only. No, in our syllabus, you need to learn everything. Yeah, because that's why we also learn period 2. Period 3. We are combining everything. Yeah, so you can still go and read more about this. Okay, but later when you see some questions, you will understand why we are learning all this. Yeah. Now, reaction with water. So when I mean reaction with water, first we are talking about the group 2 metal with water. That is very important. So let's look into the reaction with water. Yeah. So magnesium, okay, when you learn in your periodicity, you will learn that magnesium, okay, this one is from the previous chapter. You will learn, it is still repeated here. You will learn that magnesium have tendency to react with water, okay, in 2 conditions. One, they will react with water under normal condition. Okay, just cold water. It means without any heat, yeah, they can react. They will give you magnesium hydroxide and hydrogen gas. But okay, when you react them with heat, okay, it means you give them enough heat or you react with steam. Okay, the reaction is going to be more vigorous. Now, not only more vigorous, the product also is going to change. Very, very important. If you use cold water, they will give you magnesium hydroxide. If you use hot condition, let it be with steam or hot magnesium, you are going to get a very vigorous reaction. You see, very slow, very vigorous reaction. The rate of reaction, we are talking about rate of reaction because of temperature. And not only because of that, rate of reaction is increased, you are going to get a very new, a different kind of product, magnesium oxide. So this is very important. How to differentiate? You see, liquid and gas. Liquid is going to be cold water, gas is going to be steam. So they are going to have different products. And if you look at calcium, which is going to be the element after magnesium, calcium, they can react with water, but you do not need to have steam under steam condition. They say in liquid form, they will give you calcium hydroxide and hydrogen. And you can see it reacts more readily than magnesium. Now, if you compare these two, you can clearly see that, magnesium, they are struggling to react with water under cold condition. They are struggling. But if you go down a bit from the group, calcium is reacting more readily, compared to magnesium. It means that we are talking about reactivity is increasing with water. And this is understood because we already learned why the reactivity with water is increasing. We have learned that group 2, as you go down the group, they have tendency to release the electron easily. Of course, they will react more easily with oxygen. They will react more easily with water. It is understood. So you need to take note of this. You see, bright white flame, vigorous reaction. Why? Of course, magnesium, if it is bright white flame, if I'm going to react with calcium with oxygen, it's going to be more vigorous. Why? Automatically, you should know reactivity is increasing down the group. Coming back to this concept. So that is the reason, why it will become more readily reacting and so on. And when we look at solubility, there is another thing that just now I mentioned. The moment earlier you have magnesium hydroxide, magnesium oxide, but later on, you are going to get calcium hydroxide. If you have barium with water, they will give you barium hydroxide with hydrogen and so on. What can you say, look at when you compare the solubility of those hydroxide? You can see here magnesium hydroxide, calcium hydroxide, strontium, and barium. You can see that the solubility is going to be, you look at the number, the solubility is going to be increasing. The number is getting bigger. It means that your hydroxide, it's going to get more soluble. That is the reason why I mentioned earlier, when you have magnesium hydroxide, if I want to compare with calcium hydroxide, and if I want to compare with barium hydroxide, the pH is going to become greater. Why? They will give you more concentration of hydroxide ion. Because they are going to be more soluble. So that is the explanation over there, and there is a data over there. So what you need to remember for your AS, memorize only. You don't need to know why. You need to know by now. Hydroxides going down the group, they are going to be more soluble. This is very important. Going down the group, they are going to be more soluble. Do you need to memorize all this? No need. You just understand that the solubility is going to be increasing. And how do I use the data of solubility with pH? The pH is going to become bigger. The number is going to be closer to 14. Because you are going to get more OH. So you need to memorize that. So it means you can say that going down the group, solubility is increasing. You can say the pH also going to increase going down the group. So a lot of things that you can come up from here. So you can see here, I summarize this into here. Hydroxides, they become more soluble down the group. Then what you need to remember, something opposite to that, which is going to be quite simple to memorize. It's something opposite, it's like yin and yang, black and white. So if you have hydroxide in your syllabus, when they go down, they become more soluble. Then sulfate, when they go down, they become less soluble. Very easy to memorize. Okay, and how do I memorize this? Also very simple. You see magnesium sulfate. At the bottom, we have barium sulfate. And I told you, if you are a chemistry student, by now, you should know barium sulfate is a white precipitate. You should know. Okay, you should know. If barium sulfate is a white precipitate, you can say that this is already becoming less soluble. So we can deduce that, okay, we can deduce that going down group 2 sulfate, they are going to become less soluble. It means this is soluble, then they will become less soluble here. So this is another way if you want to memorize, okay. So one thing, okay, it's going to be hydroxide going down the group, they become more soluble. Okay, sulfate going down the group, they will become less soluble. Okay, this is going to be the important part under the solubility. Why? Then that is going to be supposed to be in your AS syllabus, lattice energy, but they have moved it. Yeah, they have moved it to some other part, which we will cover also in A2. Okay, but they will not ask in AS. Okay, they will ask question. If they ask similar question, why solubility become more soluble, why solubility decreasing, and so on, then if they ask you in paper 4, okay, in your A2, then there is a different way to explain. Yeah, but now you just need to memorize. Yeah. Now, group 2 carbonates with water. Okay, like just now. Okay, I told you that group 2 oxides. Okay, magnesium oxide, they don't react with water. The same thing. Okay, group 2 carbonates. Okay, they do not react with water. Okay, so there is no reaction or insoluble in water. So I just add over here similar. Okay, group 2 oxides. Okay, group 2 oxides. They are also insoluble in water. So there won't be any reaction with water also. Yeah. So on top of that. Okay, so maybe you can memorize this. Okay, there is no reaction. Carbonates with water. But carbonates, okay, they do react with dilute acid. Okay, so you can have all these reaction like magnesium carbonate. When I react with H2SO4, I'm going to get magnesium sulfate, and then I'm going to get water and carbon dioxide. How to balance the equation, everything by now you should know. Yeah. So similar, okay, they are mentioning about dilute acid. So not only sulfate, okay, you can also react with nitric acid. Okay, you can get calcium nitrate, for example. Similar, if you have magnesium carbonate, then you can get magnesium nitrate, water, and carbon dioxide. Do remember all nitrate salts are soluble. Okay, so they are soluble. But the difference for magnesium sulfate as you go down, okay, but let's say you have calcium carbonate, okay, you have barium carbonate, and then you react with H2SO4, what will happen? You are going to get barium sulfate plus water and carbon dioxide. Now, what's different over here is earlier magnesium sulfate, they are soluble. They are kind of, remember I told you sulfate at the top, they are soluble, but as they go down, they are going to give you a white precipitate. So it means they are going to be solubility is going to be decreasing. So that's the reason why they say that first, okay, they remain aqueous, okay, but later, okay, they will actually form an insoluble sulfate layer on the carbonate. Okay, so that is going to be one of the things that you need to remember as you keep on reacting group 2 carbonates. Okay, there will be insoluble sulfate layer at the top. But if you are using dilute nitric acid, we don't have any problem. Okay, when I say, for example, okay, if you have barium carbonate, when they react with HNO3, they will give you barium nitrate. Barium nitrate, they are soluble. So you don't have that problem having insoluble sulfate layers over there. Now, next part is going to be thermal decomposition. Okay, thermal decomposition, okay, you need to remember if you have carbonate, if you have nitrate, okay, when you have heat, okay, you can break them into the oxide and the gas. Like for example, carbonate, they will give you carbon dioxide. If you have nitrate, okay, they will give you nitrogen dioxide and oxygen. Very important. Okay, nitrogen dioxide and oxygen. Okay, but one thing that you need to remember for both group 2, the temperature of thermal decomposition take place increases. It means that it is going to be more difficult, okay, to decompose carbonate and to decompose nitrate. Why? Also no need to know in AS, but you will learn in A2. Okay, why it's going to be more difficult to decompose them. Yeah, so it is easier, okay, to decompose magnesium carbonate, but it's going to be difficult to decompose barium carbonate. Okay, it is easier to decompose magnesium nitrate, but it's going to be difficult to decompose barium nitrate. Okay, so you can just put as you go down the group, difficult to decompose. When we say difficult to decompose, it means if you want to decompose them, the temperature that you must use must be higher. Okay, must be higher. Okay, so you cannot just decompose them easily. Okay, so that is going to be the meaning. Now, this one, okay, please do it yourself. All taken from your textbook. Yeah, all taken from your textbook. So do remember barium carbonate, they do react with nitric acid. So you get barium nitrate. Okay, what else you will get? You will get carbon dioxide. Okay, you will get water. Okay, balance it out. Okay, which one decompose at lowest temperature? It means easier to decompose. I told you as you go down, okay, it's going to be difficult to decompose. So lower, this is easier to decompose. Okay, and then similar, barium, calcium, magnesium. Of course, magnesium will be easier to decompose. Okay, write the equation, okay, for thermal decomposition of this. Okay, strontium oxide, they will give you, okay, they will give you carbon dioxide, and they will give you, you see here, okay, strontium oxide and carbon dioxide. There is no water. Okay, there's no water, you balance. And then barium nitrate, okay, you will get barium oxide, and you will get NO2, you will get O2, then you balance it. Okay, all this you can do. Okay, please go through all this and write it down. Okay, that's why even the answers I don't put, because it's already there. Okay, it's already there. Now, uses of group 2 compounds, okay, similar if you are heating it, okay. Calcium carbonate, okay, they are going to be known as limestone. Okay, limestone, if you heat up, okay, they will give you lime, okay, CaO, and then you will get carbon dioxide, okay. This lime, okay, if you use it, okay, like for example, if you take the CaO, okay, and then you add with water, okay, you are going to get calcium hydroxide. This is what we call as lime water, okay, that we test for carbon dioxide. Okay, so this one you can also take note. Okay, so we also have this calcium hydroxide, okay, where if it is going to be in aqueous form, we call it lime water, but if it is going to be in solid form, we call it slaked lime. Okay, this slaked lime is also used to raise the pH of acidic soil. Okay, so you can use that to improve the pH, okay, to increase the pH. So you need to know all these terms. Okay, lime, okay, they are also known as quick lime. Okay, lime and quick lime, they are all the same. Okay, so please take note of this naming. Yeah. So they will just test you, okay, related on this term. Okay, limestone, okay, quick lime, lime water, slaked lime. Okay, but it's actually the same. Yeah. So that will be uses. Okay. Now straight away I will enter group 17. Okay, group 17 is much more easier to understand. Yeah. So group 17, what you need to know is going to be the color. Okay, the color of these halogens, okay, as you go down, okay, the color is getting dark. Okay, you can just go through one by one: pale yellow, green, orange or brown, okay, for bromine, and then after that it's going to be black solid for iodine, or purple vapor. Okay, so that is going to be something that you can go through. Okay, and let's say we look into the electronegativity. It is important to know what is the meaning of electronegativity. Electronegativity is the ability, okay, of this atom to pull the covalently bonded electron. Okay, covalently bonded electron. So you can see that, okay, the number, okay, the bigger the number, okay, it means it's going to have greater electronegativity. Actually, number 4 is the maximum number it can go. Okay, it means fluorine, okay, is going to be one of the atom that has the most electronegative, the most electronegativity in your periodic table. Okay, so fluorine is 4. Okay, followed by the rest. Okay, you can see fluorine have better electronegativity. Okay, to pull the electron, the covalently bonded electron. And then when we look into the reactivity, like what I said just now, group 2, okay, you have 2 valence electron, they lose their 2 electron. But this is group 17, 7 valence electron, ability to attract electron. When you look at group 17, you know that they are going to become bigger and bigger. How about ability to attract electron? This one will be able to attract electron better compared to the one that is bigger. Okay, why? Because they are further away. There is more shielding effect. Okay, the distance is greater. They are not going to be able to attract electron properly. So the one on top will be more reactive. Okay, compared to the one at the bottom. That's the reason why the halogen get less reactive down group 17. Okay, so this is very important. Just now, okay, when you go down group 2, it will become more reactive. But now, halogens, they are getting less reactive. The same applies, not only group 17, the same applies for group 15, group 16, and also group 17, yeah, for the non-metals. Okay, I will move on. Now, the important thing is about the displacement reaction. So since just now I mentioned a more reactive, yeah, what is more reactive? If you look at Cl, okay, I always remember FCBI, okay, so FCBI. So here, when I look at this, okay, I know that this is more reactive compared to Cl, compared to Br, compared to I. So it means, okay, according to displacement reaction, a more reactive halogen can displace a less reactive halogen from halide solution. Okay, so it means that, okay, like for example, if I have NaI, okay, NaI, this I is going to be a bit weak. Yeah, it's a bit weak. Okay, so this guy, just imagine this is a slim guy or something like that. And then you have, okay, you have Cl2, which is the guy that always go to the gym and actually have bigger arms, okay, and then he can actually wrestle the guy easily, okay. So he can go and take away, okay, the girl, okay, from here easily, okay, and go and kidnap her or something like that. Okay, it's separate, okay, separate, leaving, okay, this one joined together to give you NaCl, and then leaving this guy alone set. Okay, so this is what we call displacement reaction. Now, this displacement reaction is very difficult to see because you see, when I have, I might get this iodine, I might get Cl2, I might get Br2, I might get I2 over here. And then do remember NaCl, NaBr, NaI, all these, they are colorless. It's very difficult to see. Okay, it's very difficult to see. So what we do is normally for displacement reaction, if you want to see clearly, we add a solution, what we call a cyclohexane. Okay, we add, okay, it's like a region. Okay, when you add that region, okay, they will give you a 2-layer. Okay, cyclohexane and then water, they don't mix. Okay, they will give you 2 layers. And from that layer, okay, the halogens, okay, they will be dissolved. Okay, they will be dissolved in cyclohexane. Now, when they dissolve in cyclohexane, they will give you some kind of color. Okay, and that color is going to help us to identify what type of halogen is there. Okay, so it means if it is Cl2 in cyclohexane, okay, you can see that if it is Cl2, it's going to be this one, pale green. Okay, this is Cl2, pale green. If it is orange, then it's going to be Br2. If it is purple, okay, then we are talking about I2. Okay, so this is something that you need to remember. So if I put cyclohexane, okay, so if I have Cl2, Br2, and I2, I just remember pale green, orange, and then this one purple. If I can identify that, it means I'm talking about this. Okay, if you identify this, automatically you can identify what is this and you can identify what is that. Okay, automatically. Okay, so that is something that you want to also take note. Okay, next, okay, reaction with hydrogen. Now, if you look at the reaction with hydrogen, first thing that you can notice over here is when you're going through the textbook, you can see all straight arrows, suddenly there is going to be reversible reaction. The moment you see reversible reaction, you can say that the reaction is not strong. Yeah, the reaction is going to be kind of like something like weak acid. Generally, HCl, okay, HCl, we say they will give you H plus and Cl minus. If I have CH3COOH, I will have reversible reaction, and I will write it like this. Okay, it means it's not a fully ionized. Yeah, similar to that. Okay, if you look over here, it just telling us that okay, the reaction is going to be kind of becoming less reactive. Okay, less reactive. You can see here reacts explosive even in cool and dark condition. Very reactive, explosive during in sunlight, okay, and then react slowly in heating, and then after that form equilibrium mixture. Okay, it means I can say roughly over here, I can say that the reactivity is going to be decreasing. So let's actually see why the reactivity is decreasing, because I'm using this. If you are using F2, Cl2, Br2, and I2, and I mentioned just now, okay, the one at the top, okay, which is going to be more reactive, okay, and after that, they are going to become less reactive. Why? Because ability to attract electron is going to be less, okay? So you can just use that, okay? You can memorize all this, okay? You can memorize this, and that is going to be the reactivity when it comes to hydrogen. They will give you all this stuff, okay? But what we need to look later is going to be this part. Now, the moment that they form HF, HCl, HBr, and HI, okay, you are going to actually look into the bond between HF, bond between HCl, HBr, HI. I want to see whether is it easier to be broken. Okay, you see hydrogen, okay, they are going to be same size. Okay, F maybe this size. Hydrogen same size, Cl is bigger. Same size, Br is bigger, same size, I is bigger. So if you look at the bond length, okay, the bond length is going to increase. Okay, so if I want to see whether which can I easily break this, okay, it's like, you know, in martial arts they actually ask you to break the board of plywood or something like that. It will be much more easier if the plywood is going to be longer. Yeah, so it's going to be, you just use your hand, yeah, it is going to be easily broken. So the same thing in chemistry, if you have bond length which is going to be longer, okay, it is going to be easier to be broken. So you need less bond energy. The bond energy is lower, less energy is required, okay, to break the bond between H and F. So that's why you can see that HI is going to be easily broken compared to HF. That's the reason why they say least thermally stable. Okay, it means easier to be broken. Okay, so if you have this, okay, why it is easier to be broken, you need to know that. Okay, you need to know, you can compare the bond energy. You can see HI, if you compare with HF, okay, the bond energy is going to be lower. Okay, easily be broken. Why? Because the bond length is more. Okay, that's why they are easily broken. Okay, I have 7 minutes only. I have to go. Yeah, I have to make it faster. Okay, testing for halide ions. Okay, this one I'm not going to discuss a lot. Yeah, you need to know. Okay, if I have silver ions, okay, silver ions, and I have this Cl. Okay, if I have Cl minus, AgBr. Okay, and then if I have Agi, okay, they are going to give you the precipitate. Okay, so this is going to be white, this is cream, this is yellow. Okay, so this is AgCl, AgBr, and this is going to be AgI. But sometimes we do not have this kind of situation, because this precipitate will appear based on the amount of the substance that we use. Okay, so it will not be always like this. So sometimes these two might look similar. Sometimes these two might look similar. So what I need to do is I need to add ammonia. Now, when you add ammonia, then we can actually identify further. There are two types. You add dilute ammonia or you add concentrated ammonia. Now, if you add dilute ammonia, okay, silver chloride, they will dissolve. Okay, so no need to add concentrated, it will automatically dissolve. Okay, but if you add dilute for the bromide, they remain insoluble. Okay, but you add the concentrated, the stronger ammonia over there, they will dissolve. Okay, but when you have for iodide, silver iodide, the yellow precipitate, when you add dilute ammonia, they remain insoluble. When you add concentrated ammonia, they also remain insoluble. Yeah, this one you need to remember. Yeah, very important. Okay, so this one I will just skip. Yeah, please learn. Yeah, please learn. Yeah. Now, this is also a very important part. Okay, the reaction of halide ion with concentrated sulfuric acid. Remember, I think when we did our organic chemistry, we actually have something similar to this. Okay, where when you are preparing something in situ, okay, remember we want to have this HCl. Okay, we prepare HCl, okay, using NaCl plus H2SO4. Yeah, I hope you remember, okay, the reaction that we have learned recently. But if you don't remember, it's okay, fine. Okay, you can just revise again. NaBr, okay, if you react with H2SO4, you are going to get NaHSO4 plus HBr. So you can prepare the HBr this way. Yeah. Now, but okay, sorry, I think I'm supposed to start from here. Sorry. You can prepare NaCl with H2SO4. You can prepare HCl this way. Okay. But okay, if you are thinking that you can use the same method using NaBr plus H2SO4, you are going to get this, and then I'm going to get HBr. The answer is wrong. Why? Because H2SO4 concentrated is a very strong oxidizing agent. So what it will do, it will further oxidize the HBr. But earlier, okay, when you have H2SO4, when it forms HCl, this acid is not good enough to oxidize the HCl. So they will stay. The HCl will stay. But now the problem is HBr will not stay. So what happened? The HBr will continue to react with H2SO4. They will give you Br2, SO2, and H2O. So it means you are not going to have HBr anymore. So that's the reason why you cannot prepare HBr using this method. Okay, you cannot prepare. Okay, because okay, the HBr, okay, they will be broken. Why they will be broken? Remember just now I told you HCl, HBr, HI. Okay, the longer, okay, the bond length, okay, is going to be easily be broken. So this one difficult to be broken, but this one can be easily broken. Can be easily broken by what? In this case, sulfuric acid will break them. Yeah, so this one you need to know how to write equation. The another thing that is going to be we need to remember, yeah, of course, if you're using NaI, okay, with H2SO4, you will get a mixture of product. Okay, you suppose you be thinking that you are going to get HI, but this HI, they are going to be further oxidized to multiple products. Okay, you can get I2, all of them will give you I2, but they will give you SO2 and water. They will give you sulfur and water. They will give you H2S and water, and all of them are going to happen together. It means, okay, you are going to get acidic gas, you are going to get yellow solid, you will get a rotten egg smell. Okay, all together. Okay, all together. And do remember, I2 is purple gas. Okay, so that's why you will get all of them together, but you will not get HI. This one will not be there. Okay, so the next part is going to be, okay, I just will go through very fast over here, disproportionation reaction. Now, disproportionation reaction, you need to memorize. Okay, what is disproportionation reaction? Okay, if you have 1 over here, 0 oxidation number, here the oxidation number of Cl is -1. If you count, this is going to be +1. Okay, of course, how to count and so on, please learn under redox. Yeah, so you can see when the same element is being in the same equation, being oxidized and reduced. Okay, here is reduced, here is going to be oxidized at the same time. Okay, that is called disproportionation reaction. What you need to know is to know and memorize how to write this equation. Okay, memorize. Okay. Of course, I have created a video on how to balance this equation without memorizing. You can also check. Yeah, but I will just put it over here. Yeah, 15 degrees Celsius in cold alkali, you are going to get NaCl, NaClO. Yeah, if you have 70, okay, you are going to get NaCl, NaClO3. Okay, and if you go to the next page, okay, in your textbook, they have a reaction with bleach. Okay, that is also a disproportionation reaction. Cl2 plus water give you this HCl, HClO. Okay, you need to also memorize this. Okay, so this one, okay, please read. Okay, please read. I wanted to do a quizzes also, but we can do it tomorrow, no problem. Okay, but if you look over here, there are some questions about which property shows increase from magnesium to barium. Okay, I can see, okay, if you look at the solubility, okay, solubility of the hydroxide will increase. Okay, I think if you don't want to go through everything, I think that is definitely correct. Hydroxide will increase. The rest you can eliminate. Ionization energy, will it increase? No, the ionization energy will decrease down the group. Okay, oxidizing power. What is oxidizing power? Oxidizing means they are going to oxidize others. Okay, when they oxidize others, okay, they themselves will get reduced. What is reduced? Okay, remember oil rig? Reduce is gain electron. Okay, so are they going to be able to gain electron easily? Okay, so if you look at magnesium all the way to barium, can they gain electron easily? Okay, this one is going to have difficulty in gaining electron. So this one is wrong. So this is how you get this answer. Yeah. So the next questions are something like, you see, metal T react with water to give you colorless solution. A white precipitate is produced when you have sulfuric acid. So we are talking about sulfate. What sulfate is white? Barium sulfate. So automatically the answer should be barium. Okay, so all these are the things that you need to know. Okay, you can go through. Okay, I gave another 2 questions over here. I think maybe this one maybe require more time, but this one, you see, sodium bromide react with concentrated sulfuric acid. What observation will be made? Remember just now, you will not get HBr. Okay, that HBr will further react, okay, to give you Br2 with what? SO2. Okay, they will give you SO2. Okay, so see which one will be SO2. Purple solid, no. H2S, no. Okay, yellow sulfur, no. Halogen that dissolve in cyclohexane layer give orange color, Br2. Okay, it's the answer. Okay, so you can go through this. Now, I know you have another class and so on. Okay, if you look at the at your WhatsApp, okay, the link that I've shared to you, okay, that link will give you lead you to this Google Drive. Okay, if you go to that Google Drive, okay, you can go through all this. Okay, you can see there are notes on group 2 and group 17. Okay, the one that I did last time. Okay, you can just go through that as well. Okay, I think I'll just show you some. Okay, so there are information over there where you can use that to study further. Yeah, so please go through all this. Okay, links. Okay, I do not know whether you can still hear me. Okay, but anyway, okay, please go through. Okay, I think my internet connection got weak towards the end. Please go through that Google Drive that I shared to you guys. Yeah, that's it from me today. That's all. Yeah, that's all, guys. Okay, see you. Okay, please revise. Okay, please revise. Go through the notes that I've given you. Yeah, see you.
Bye, sir.
Bye,
Yeah,
sir.
you too.
Sir.
Bye, sir.